This is lesson 7.3a. You've already seen multiplying and dividing radicals, so today we're going to talk about adding and subtracting radicals. Page 12 in your notes is where we're starting, and in order to start talking about adding and subtracting radicals, we have to understand this idea of like terms. So remember that like terms are things like 2x and 7x, or 3xy squared and 10xy squared. The idea being that they have the same variable, but also the same exponents. So if I was suddenly to throw in a 12x squared y squared, that would not be a like term with the 3xy squared, 10xy squared. It has to be the same variables and the same powers. Similarly, for a radical, you must have the same index and the same radicand. So remember, when we're talking about a radical, this is your index right here in front, that number, and the radicand is the stuff on the inside. So if you have those two things, you have a like radical. For example, 3 root 14 and 6 root 14 are like radicals. It's the same number. And so we simply ask ourselves, how many do we have? We have 3 plus 6, therefore we have 9 root 14s. Now, when you do not have like radicals, for example, when you have root 12 and root 27, you cannot combine them. However, you are allowed to go ahead and break them up into pieces. So the root 12 breaks up into a root 4, root 3. The root 4 comes out as a 2, so you get 2 times 2 is 4, root 3. And then similarly, the 27 breaks up into a root 9, root 3. The 9 comes out in front, root 3. Now you do have like radicals. You have 4 of them plus 3 of them, so you have 7 root 3s. Sometimes when you have like radicals, like root 5 plus root 12, they don't look alike, but when you try to simplify them, and we break this up into 4 times 3, we still have radicals that are not alike. And so your final answer will have 2 radicals in it because you can't combine them any further. It's simplified, but you can't combine. Scrolling down your page then to look at some of these examples. Your first one has root 7 and root 7. So we can combine these. We can say we have 5 root 7s. Your next one has variables in it that you have root xy and root xy. You have 4 of them plus 5 of them. So you have 9 square root xy. And then for this last one, we notice that you have cubed roots for both of them. However, the insides, the radicands, are not the same. So we leave it as it is. We cannot combine. It's already simplified. One other example we want to point out for you is that let's say you have a 4 square root 7 minus a square root 7. And just to point out that if there is no number written in front of a radical, it's like having a 1 hiding in there. So it's 4 minus 1, or 3 root 7. So no number means a 1. The last 2 examples for this lesson are examples where, again, they start off looking very different. So square root 20, square root 25, square root 80. Make sure that you break these up for me, please. So you have 3, and 20 breaks up into 4 times 5, minus 9 times 5, plus 4. 80 will break up into 16 root 5. We'll go ahead and we'll pull out our perfect squares. And then multiply those with your coefficients in front, with our root 5s left over. So we end up getting 6 root 5 minus 3 root 5 plus 16 root 5. Combine these all together, we will have a 19 root 5. Again, because all of these pieces are the same. Now, for our last example here, we're going to actually tack on something new. So please, in your notes, tack on at the end a plus root 75. We're going to pretend that this has been here. When we do this, when we break up inside of our radicals, we're going to get 25 times 2, and then 32 will be a 16 times 2, and 18 will be a 9 times 2. The root 75 will be a 25 times 3. When we pull out the perfects, we'll have 5, 4, 3, and 5. Then go ahead and pull out your root 2's and your root 3's. And don't forget your leading coefficients in here. So we end up getting 5 root 2 plus 12 root 2 minus 15 root 2 plus 5 root 3. When this happens, you have similar things in your radicals for the first three, but notice your last one is different. That's okay. You simply combine the ones that are alike. So 5 plus 12 is 17, minus 15 is 2 root 2. This is a different radical, but we'll just leave it at the end. And there's your final answer.